Wind and slope are often considered separately in fire line assessments. In fact, they are measured differently, with winds measured in speeds, for example miles per hour, and slope measured as steepness, usually measured in percent rise over run. When estimating expected fire behavior, wind and slope are combined into a single estimate called effective wind speed that is then used to estimate the initial spread index. In this presentation, we will discuss how to estimate the wind speed that will be most useful to the FBP assessment process, how to incorporate slope steepness into the estimate of an effective wind speed, and how to update your daily ISI for local conditions as the winds change throughout the burn period. On the fire line, you recognize changes in wind speed and slope that affect your fire as it is burning. The Fire Assessment Worksheet points you to the process of adjusting ISI for local conditions. Estimating expected wind speed and the steepness of the slope where your fire is burning will allow you to update the initial spread index, or ISI, that you will use in fire behavior predictions. There is both an ISI for estimating head fire spread and a backing ISI for estimating backing spread. Wind speed and direction are the most changeable factors affecting the fire behavior during a burn period. They are affected by weather systems, local vegetation and slopes, and other terrain features like mountain gaps and large bodies of water. Along with the FFMC, wind speed is a key input to the initial spread index. When, where, and how you measure wind and slope affects the usefulness of your winds and your ISI estimates. The Fire Weather Index, FWI, and Fire Behavior Prediction, FBP systems expect winds collected at a 10-meter height above typically open settings in forest surroundings. On the fire line, you will frequently get your current wind speed estimate from handheld meters like kestrels and psychrometers. These generally come from a height of 5 feet or 1.5 meters. And many of our RAWS weather stations have wind meters mounted at the top of a 20-foot mast. You will want to make sure that the ISI you estimate reflects wind speeds from a typical 10-meter observation. More importantly, you'll need to factor in the surrounding terrain and cover when making that 10-meter wind speed estimate. How flat and open is the surface around you? Does your position in terrain enhance or reduce wind exposure? We use ASOS weather stations at airports for our FWI system. Frequently, they produce higher wind speeds. Consider whether the wind speeds in the forecasts are higher than the typical forestry or fire RAWS wind speed that we commonly measure. Those who have completed S290 have learned about adjusting 20-foot wind speeds to a mid-flame wind speed. This table in your field guide allows you to quickly convert any wind speed measurement to any other in the field without calculation. You can estimate your wind speed from eye level, 6 feet, from a RAWS site at 20 feet, or an ASOS station in an airport at 10 meters. In this table, you will find your wind speed in the column that makes sense. You'll follow across to the forestry RAWS column, and there you will read the 10-meter wind speed that the FBP system is expecting. Conversions are built into the ISI table itself. These are for forested landscapes. Each height is represented. Use whichever makes sense for the wind speed that you have. Is it from a forecast, a 10-meter station, a 20-foot mast, or an eye-level observation in the open? In this example, eye-level wind speed is 3 miles an hour and the FFMC is 82. Finding the intersection shows you that the ISI can be estimated to be 2. If you're on steep slopes, Note the 10-meter wind speed. You'll need it later. Your task is getting a good estimate of the surface or 10-meter wind speed for the FBP system. You can estimate wind speed from this modified Beaufort scale. Try it. With practice, you can be good at it. You can set the wind speed from one of our RAWS stations, or from a weather forecast, or measured from an airport, or even perhaps from the fire line. The wind adjustment factors you learned in S290 are not needed for the FBP assessment system. REDAP and Behave Plus are computer programs that estimate expected fire behavior. They combine the influences of wind and slope into an effective wind speed within the black box. Using this field guide, though, you will have to do it yourself. If there is a significant slope, you will have to estimate a slope equivalent wind speed and add your wind speed measurement or forecast to it. This table, using slope and fuel type, provides a slope equivalent wind speed. In this example, the fire is burning in a C2 fuel type on a 20% slope. The slope equivalent wind speed is 5 miles per hour. If the fire is expected to burn up slope, add the slope equivalent wind speed to your wind speed estimate. If it's downslope, subtract it. The final step is updating the initial spread index for your local conditions. The notes on your fire behavior assessment worksheet might look like this. In this example, your FFMC is 90 and your effective wind speed is 9 miles per hour. The 4 miles per hour wind speed blowing up slope plus the 5 miles per hour slope equivalent wind speed. Find the effective wind speed as the 10 mile per hour wind speed and the FFMC in the ISI table. Using the ISI table from your field guide, you can estimate the ISI to be 8.9 or simply 9. If you want to estimate backing fire behavior, use the backing initial spread index table from your field guide. With the same example, the FFMC is 90 and the effective wind speed is 9. The backing ISI is 2.1 or simply 2. Effective wind speed is an important concept. Field methods for converting slope to an equivalent wind speed make it easy to produce a fire behavior estimate with it. If your winds are blowing up slope, add the slope equivalent wind speed to your estimated wind speed to get an effective wind speed measure. If your winds are blowing down slope, subtract one from the other. Estimate the ISI and the BSI using the effective wind speed you just estimated. And finally, you can use this ISI and BSI value to estimate expected fire behavior using the fire behavior tables in your field guide. Wind speed and slope are critical big change factors when estimating expected fire behavior. They can produce big changes in the initial spread index. Remember to first estimate the wind speed expected to influence your fire. Think about when it will change. Make sure that you adjust the wind speed, accounting for measurement height, and get your best ISI estimate if it comes from a local forecast or if it comes from the fire line. Again, make sure you know the effective wind speed as if it came from one of our RAWS stations. There are other topics that can help you learn to use the FBP system. Consider taking the time to view them as well. Thank you.